Hello friends, let's start with another session of linear programming problem in which we use graphic method to solve the problems. So in this problem we need to find out the maximum profit which is generated by the objective function z is equals to 3x plus 4y. So let's find out the value of x and y which satisfies this linear inequalities. As the solution needs to be found using graph, let's represent these inequalities into the coordinate plane. Now how to graph the inequalities? So that we will first write the corresponding equations. So my corresponding equations for these two equations are 4x plus 2y is equals to 80 and 3x plus 5y is equals to 180. Next we need to graph the lines of the inequalities, and we can do that by coordinate of x and y intercepts. So we have to find out the coordinate of x intercept and coordinate of y intercept. Now how to do that? For this, first of all, for this equation, that is 4x plus 2y is equals to 80. So in order to find the coordinate of x-intercept, first of all we will put the value of y as 0. So if we put value of y at 0, the equation will be 4x plus 2 into 0 is equals to 80. So the value of x is 20. In this way, we will be able to write that the coordinate of x-intercept is 20 and 0. In the same way, we find out the coordinate of y-intercept. For that, we put x is equals to 0 and my equation will be 4 into 0 plus 2y is equals to 80. So the value of y in this case is 40. So the coordinate of y-intercept for first equation is 0 and 40. In the same way, now we will take the second equation. 3x plus 5y is equals to 180. So first of all, I'll put y equals to 0. So in this case, my value of x is equals to 3x plus 5 into 0 is equals to 180. So the value of x is equals to 60. So the coordinate of x-intercept is 60 and 0. In the same way, now I will put the value of x as 0. So I will get 3 into 0 plus 5y equals to 180. So the value of y is 36. So the coordinate of y-intercept is 0 and 36. Now the next step is that we have to plot these values, that is of coordinate of x and coordinate of y, on graph. So let's move toward the graph. This is my x-axis and this is my y-axis. So now I will put the value of these coordinates on my graph. Now I will put the mark on these values. So the first we have is 20 and 0. That is 20 for x and 0 is for y. And in the same way, here I have 40 and 0 and 40. And again, I will put another value, that is 36 and 0 for x, 36 for y-axis and 60 on x-axis. Now I will join these 2 points. So this way we may able to make a graph. Now we have to find out the feasible region. Now the question is, what is feasible region? Basically the feasible region is that in which the common region is determined by all the constraints. Now if you look at these two equations, in both the equations the sign is less than and equals to. So we have already discussed this thing that whenever we have less than and equals to sign, it means that common area lies toward the origin. The common area of this first equation, if we try to find out, is toward the origin. It means this side, that is less than, and for other equation again it is this side, that is less than. So we can say here that my common area is from this point to this point, and then this line following by this line. So this area is my common region, right? This is my visible area. The whole area is visible area, but this is my common region. So I have to find out the optimum solution. Now, what we can do for that? As you see here that there are 4 points. 1, 2, 3 and 4. So we have 4 points. We can denote it as O, A, B and C. We have 4 points here. Now these points are known as common point, and the method which we are going to use to solve this is the corner point method. Now what is corner point method? Corner point method is the method for the solution of LPP in which the corner points are used to find out the feasible region, and which comprises of the coordinates of these 4 common points. So we have O, A, B and C. Now we will evaluate the objective function by substituting the values of corner point in maximization equation. You can see here at point O, the coordinates are 0 and 0. At point A, the coordinates are 0 and 36. At point C, the coordinates are 20 and 0. But it is difficult for us to find out the coordinates of point B. You can see here that the two lines are intersecting at point B. So in this case, what we will do, we will equate these two lines in order to find out the coordinate at this point. We will write 4x plus 2y is equals to 80 and 3x plus 5y is equals to 180. Now in order to equate these two equations, let's suppose this is my first equation and this is my second equation. We will multiply equation 1 with 3 and equation 2 with 4, and then we will subtract these two equations. So I will write equation 1 multiply with 3 minus equation 2 multiply with 4. So we will get 12x plus 6y is equals to 240 and 12x plus 20y is equals to 720. Now when we subtract these two equations, we will get minus 14y is equals to minus 480. So the value of y is equals to 34.3 approximately. So when we substitute the value of y in any of these equations, we get the value of x as 2.85. Right? So the coordinate for B point is 2.85 and 34.3. So now we have to substitute these 4 values in maximize equation. Now the maximize equation for the given question is 3x plus 4y. So I will substitute 3 into 0 plus 4 into 0. This will give me the value of 0. Next, 3 into 0 plus 4 into 36. This gives me the value as 144. In the same way, if I put 3 into 2.85 plus 4 into 34.3, this will give me the value 145.75. And the last is 3 into 20 plus 4 into 0. This will give me the value of 60. Now we have all the 4 values of z using corner values for the feasible region. Since our objective is to maximize the z, so the value at point B, that is 145.75, is the maximum value out of the 4. And the coordinates here are 2.85 and 34.3. So this is how we can say that the value for the maximization is 145.75, where the value of x is equals to 2.85 and the value of y is 34.3. So this way we will able to calculate the optimum value. I hope the concept is clear to you. See you soon in the next session with some more practical questions related to graphic method. Thank you.